Hello and welcome students. Today I am going to deliver a lecture on wheat milling and testing. Let's first try to have a look at the main objectives of today's deliberation. To give a brief idea about the morphology and anatomy of wheat grain, explaining in detail the process of milling of wheat, to briefly describe about milling quality, to discuss about the types of wheat flours, and finally to learn about testing of wheat flours. Let me begin with the introduction about milling. Milling is an ancient art. In simple terms, its objective is to make cereals more palatable and thus more desirable as food. The aim of milling of any cereal is number 1, to grind cleaned and tempered cereal, number 2, to completely separate the bran and germ from mealy endosperm, which is then thoroughly pulverized into middlings, semolina and flour in case of wheat. Let's now discuss the morphology and anatomy of wheat grain. Wheat with different species like Triticum aestivum, Triticum durum, etc. is a single-seeded fruit 4 to 10 millimeter long, consisting of a germ and endosperm enclosed by an epidermis and a seed coat. The fruit coat or pericarp is 45 to 50 micrometers thick, which surrounds the seed and adheres closely to the seed coat. The color of wheat depends on the species and other factors. Hence, there are red to white varieties of wheat, and the color is due to material present in the seed coat. Wheat is also classified based on physical characteristics such as red, white, soft, hard, spring or winter. The outer pericarp is composed of the epidermis and hypodermis. The epidermis consists of single layer of cells that forms the outer surface of kernel. On the outer wall of the epidermal cells is the water impervious cuticle. Some epidermal cells at the apex of the kernel are modified to form hairs. The hypodermis is composed of 1 to 2 layers of cells. The inner pericarp is composed of intermediate cells and cross cells inwards from the hypodermis. Long and cylindrical tube cells constitute the inner epidermis of pericarp. In the crease, the seed coat joins the pigment strand and together they form a complete coat on the endosperm and germ. Thus, 3 layers can be distinguished in the seed coat: a thick outer cuticle, a colored layer that contains pigment, and a very thin inner cuticle. The bran comprises all outer structures of kernel inwards to, and it includes the aileron layer. This layer is the outer layer of the endosperm but is also considered as part of the bran. The aileron layer is usually 1 cell thick and surrounds the kernel over the starchy endosperm and germ. The endosperm is composed of peripheral, prismatic and central cells that are different in shape, size and position within the kernel. The endosperm are packed with starch granules which lie embedded in the matrix that is largely protein. Wheat grain contains 85% endosperm, 3% germ and 12% bran, all three nutritious in their own way. Now let's try to discuss about the process of milling of wheat. Wheat is commonly consumed in the form of flour obtained by milling the grain, while a small quantity is converted into breakfast foods such as wheat flakes, puffed wheat and shredded wheat. Two main objectives of wheat milling are: number 1, to separate endosperm of the grain from bran and germ; number 2, to reduce dimensions of endosperm particles for fine flour particles. There are two main types of milling processes for the wheat, that's traditional milling and modern milling. Let's know about them in detail. Number 1, traditional milling. The traditional procedure for milling wheat in India has been stone grinding, that is chakki, to obtain whole wheat flour, that's atta. By this method, 90 to 95% extraction rate of flour is obtained. Almost all the nutrients of the grain remains intact in this process, but indigestible portions like cellulose and phytic acid, which binds to required nutrients like minerals, are removed simultaneously. Number 2, modern milling. Modern milling process consists of following steps. Number 1, grain cleaning. Number 2, tempering or conditioning. Number 3, roller milling. Number 4, sieving. Number 5, commercial flour mixing. Let us discuss these one by one. Number 1, grain cleaning. Wheat separators and destoners or combination cleaners are used to remove dust and large impurities. Grain contains various types of impurities together with damaged, shrunken and broken kernels. The process of separating these impurities is collectively known as screening. A magnetic separator removes any trump metal. A milling separator removes sticks, stones and other foreign material which is either larger or smaller than the grain being cleaned. Basically, this machine removes chaff, small pieces of straw, etc. by aspiration. The grain is then fed into sieve larger than the desired grain, which removes large material including other larger grains. The next sieve retains the desired grain but removes smaller grains by allowing them to pass through. Overall, there are different principles of separation used in wheat cleaning. These include separation based on differences in size, shape, terminal velocity in air currents, specific gravity, magnetic and electrostatic properties, color, surface roughness, etc. Number 2, tempering or conditioning. The term conditioning implies the use of heat in conjugation with water to mellow endosperm. To improve the physical state of grain for milling, conditioning or tempering of wheat precedes the actual milling process. This process involves the addition or removal of moisture for a definite period of time to obtain desired moisture content in grain. Number 3, roller milling. The grinding of most cereal grains, particularly having a crease, is done with a roller mill. Around the year 1850, first time in Switzerland and later in Hungary, the concept of using porcelain or steel rollers came to existence instead of millstones. Roller mills have following advantages over traditional stone mills. Number 1, the capacity of roller mill is much larger than the windmill or water mill. Number 2, the range of products from a roller mill is larger and better in quality for industrial processing. Number 3, roller miller does not require the laborious and time-consuming sharpening of the furrow edges of the millstones. Main stages of roller milling are: Number 1, breaking stage, where the grain is opened mainly by shearing to produce 4 to 5 breakings, result in coarse parts of grains, small part of endosperm as pure semolina with very small amount of flour. Number 2, reduction stage. It is the intensive extraction of all resting parts of endosperm and finally also aleurone layer to produce smooth flour. End product of the reduction system are mainly fine offals, that is shots, and fine endosperm particles, that is flour. Number 4, sieving. A sieve is known as plan sifter, which is a complex assemble of sieves allowing to collect single fractions as over sieve or under sieve. Number 5, commercial flour mixing. During commercial flour mixing, flour is obtained in every step of breaking, reduction and purification in different percentages. Ash content and color changes with first breakings, which is lighter with low ash, to the last reduction where the flour is dark and with high ash. Next is the milling quality standardization. In commercial milling, maximum yield of flour with a healthy white color is major requirement. Lower the ash content, the whiter the flour. The milling quality of wheat is determined by successively measuring the following characteristics in a standard milling process. Number 1, the amount of grain that can be milled per unit time. Number 2, the flour yield of each milling passage. And number 3, the moisture and ash content of each milling passage. Now let's discuss the types of wheat flours. There are many types of wheat flours, and these include: number 1, all-purpose flour or plain flour or white flour. It's made from blend of hard and soft wheat. This type of flour has a moderate amount of protein and starch content that makes it suitable for either breads or cakes and pastries. Number 2, bleached flour. When freshly milled flour is slightly yellow, to whiten it, manufacturers let the flour age naturally. However, this stage is accelerated by adding chemicals such as benzoyl peroxide or acetone peroxide. Number 3, bread flour. This is made entirely from hard wheat. High gluten content helps bread rise higher because the gluten traps and holds air bubbles as the dough is mixed and kneaded. Number 4, bromated flour. Sometimes maturing agents such as bromate is added to flour to further develop the gluten and to make the kneading of dough easier. Other maturing agents like phosphate, ascorbic acid and malted barley are commonly used. Number 5, cake flour. It's finer than all-purpose flour. Cake flour is made entirely from soft wheat. Because of its low gluten content, it is especially well suited for soft textured cakes, quick breads, muffins and cookies. Number 6, durum flour. The highest protein content of durum flour can produce the most gluten. It is frequently used for pasta. Number 7, farina. Farina is milled from the endosperm of any type of wheat except for durum wheat, which is milled to make semolina. Farina is primarily used in breakfast cereals and pasta. Number 8, gluten flour. It's made so that it has about twice the gluten strength of regular bread flour. This flour is used as a strengthening agent with other flours that are low in gluten producing potential. Number 9, instant flour or granulated flour. It's mainly used for thickening savory sauces and gravies. It's designed to dissolve instantly in liquids, whether hot or cold. But it's not good for baking because of its very fine powdery texture with high starch content. Number 10, pastry flour or cookie flour or cracker flour. This flour has gluten content slightly higher than that of cake flour but lower than that of all-purpose flour, making it well suited for fine, light textured pastries. Number 11, self-rising flour. Soft wheat is used to make this flour, which contains salt, a leavening agent such as baking soda or baking powder, and an acid-releasing substance. Self-rising flour should never be used in yeast-leavened baked goods. Number 12, semolina. This is coarsely ground endosperm which contains no bran and no germ of durum wheat. Its high protein content makes it ideal for making commercial pasta, and it can also be used to make bread. In addition to these, there is whole wheat flour. This is formed during roller milling, where the bran and germ do not get separated from the endosperm. The three components actually have to be reconstituted to produce whole wheat flour. The germ and bran are visible in the flour as minute brown flecks. Because of the presence of bran, which reduces gluten development, baked goods made from whole wheat flour are naturally heavier and denser than those made with white flour. Many bakers combine whole wheat and white flour in order to gain attributes of both. Now, let's discuss another part of today's lecture, that is testing of wheat flour. The products of wheat milling are tested through analytical methods for determination of moisture, ash, protein, gluten contents, falling number and sedimentation value. Let's explain them one by one. Number 1. Moisture. It is determined gravimetrically by heating the sample to 800 degrees Celsius for 30 minutes and cooling the material in a desiccator. The difference in weight is expressed as moisture percentage. Number 2. Ash. The material is completely burned in a muffle furnace and the residue left is known as ash. Number 3. Gluten or protein. Gluten is responsible for the elasticity and extensibility characteristics of flour dough. Number 4. Combustion nitrogen analysis. It is one of the several methods used to determine protein content in flour or wheat. Number 5. The wet gluten test. This provides information on the quantity and estimates the quality of gluten in wheat or flour samples. Wet gluten reflects protein content and is a common flour specification required by end users in the food industry. Number 6. Falling number. The falling number instrument analyzes viscosity by measuring the resistance of a flour and water paste to a falling stirrer. This is dependent on the enzymes in the flour. The level of enzyme activity measured by falling number test affects the product quality. For example, yeast in bread dough requires sugar to develop properly and therefore needs some level of enzyme activity in the dough. Since starch provides the supporting structure of bread, too much activity results in sticky dough during processing and poor texture in the finished product. If the falling number is too high, enzymes can be added to the flour to compensate. If the falling number is too low, enzymes cannot be removed from the flour or wheat, which results in a serious problem that makes the flour unsuitable. Next is the rheological parameters, which are evaluated using various methods, and these include: Number 1. Sedimentation value. Swelling of the gluten fraction of flour in lactic acid solution affects the rate of sedimentation of a flour suspension in the lactic acid medium. Higher the gluten content and better gluten quality both give rise to slower sedimentation and higher sedimentation test values. Number 2. Farinograph. The farinograph is a tool used for measuring the shear and viscosity of a mixture of flour and water. The primary units of the farinograph are bar bender units, which is an arbitrary unit of measuring the viscosity of a fluid. Number 3. Extensograph. The extensograph records the exerted force as a function of stretching length, that's time. This helps in understanding the flour quality and the suitability of the flour for the production of various products. This also helps in understanding the influence of flour additives on the flour characteristics. Number 4. Alveograph. The alveograph is a tool for flour quality measurement. It measures the flexibility of the dough produced from the flour by inflating a bubble in a thin sheet of dough until it bursts. The resulting values show the strength of the flour and thus its suitability for different uses. Number 5. Amylograph. It's an instrument that measures and records the gelatinization temperature and viscosity of pastes of starch and flour. Number 6. Fermentograph. The fermentograph measures the production of carbon dioxide during dough fermentation as necessary for fluffing up the dough. Number 7. Meteorograph. Meteorograph measures in detail the individual phases of baking process. Number 8. Spring oven test. The oven spring apparatus is used for the volume determination of the optimal proofing loaf based on the meteorograph results, and it changes during baking in oil bath with temperature increasing from 30 to 100 degrees Celsius. Number 9. Baking test. The baking involves high-speed dough mixing and a short fermentation time. Dough pieces are rested for 30 minutes, sheeted and molded, placed in tins and baked. The loaves are evaluated the following day for volume, shape, crust color, crumb structure and crumb texture. Currently, various other types of testers are developed using a number of highly automated equipments to test the quality of the flour to design new types of wheat-based products. That's all about today's lecture. Hope you have understood it well. Thank you very much and goodbye.